Yep.
Okay, we're going to take a look at the master RTU. In this case, it's a RUG 3, but it could be different models and different brands of PLC, but basically speaking, this is the one we like, and we can adapt to any others. So we turn on our system, and we turn on the radio, and we're capable of broadcasting to one or more remote slave stations. Inside the unit, you can see a small battery, a radio, terminal strip, the backside of the controller, and our switchgear. Very easy access. Now we're going to go through the screens. Each screen on all of our systems indicates what it is, the time and date of the system. We move the screen to the next one by going the up or down arrows. This says this address, the battery voltage. It identifies the battery sensor number and the gate position that it's receiving from the slave, the level of the sensor, the level sensor that's attached to the slave unit, and then the target gate position. This also tells us whether there's the software limits, the low or high are enabled in any way. In other words, has it hit the limit that it's supposed to be stopping at for any reason. And then it tells the last received transmission time that it received the signal. The next screen is the control screen. It tells us the current gate position, the level sensor reading, the target position that we're trying to achieve, and the gate limits, whether they're low or high, have been enabled. And then it allows us to set a new target, and it allows us to turn the HOA or the actual mode of the operating system on or off. So we're going to set a target. And it's going to communicate that target to the slave, and the slave is going to try and achieve that target. In fact, it did. So what we can do now is go into the manual mode, and we'll just move this thing way out of line, and we'll watch it hit the target again. In this particular setup, it's designed to look for a target and make a movement every couple of seconds. And then it has a very short lag time to wait for a new adjustment because we're not in the real world. In the real world, we'd be accounting for water, and water needs time to adjust. So we have a lag time that we can put in. There we are. Okay, so on the screen on the remote RTU, we also have two screens. Now, I refer to this as an RTU. Actuator, it's an actuator, which has the motor and the whole system to run the gate, but it also is an RTU embedded within it. So it's actually doing two jobs. It's an RTU and an actuator. And the switchgear on the side is, once again, on and off for the computer. Here's our fuse for the whole system. Our auto manual, up and down momentary, that allows you to adjust the gate manually, and an external power connector in case for any reason the system doesn't have power. You can attach a battery pack to it and make it operate. The first screen, once again, gives you the time and the date. the address of the system, and local data, gate position, the level sensor, and the target. HO means, 1 means that it's in the automatic mode. It's enabled. -1 gets you to the screen control system. We go 1, we go to the gate position, gate control screen again. Here's our target, our level, and our target for the position that we want to set. So in other words, that's the gate position, that's the target. We set those in the master RTU, but we can also set them right here by going to set points. This will all be in your manual, and you can deal with targets. Deadband is the plus or minus target that you're willing to accept. The duration is the minimum pulse duration for the motor to move either up or down. In this case, it's 2 seconds. The maximum duration, in this case, the pulse duration is 5 seconds. In other words, if it's a long ways away, it will calculate how far away it is, and if it's a long ways away, it'll say, well, I can actually go to a maximum of a 5-second pulse to try and get there. And the total duration between cycles of taking a look at making an adjustment is 10 seconds. Now, that's to give you 5 seconds of lag time. In most cases, it would be many more seconds than that to let the water adjust or to let whatever systems you have settle down before you want to make another adjustment. Minus gets you to the main menu. 1 gets you to the selection of screens. 0 gets you to the main screen. Go down 1, that tells you the address. And my favorite, what's the gate position now and what's the level on the sensor. Okay, so that tells you a little bit about that's embedded RTU in the actuator. I'm going to close this, point out a couple features of the gate. These blue units right here are your limit switches. When they are actuated, they stop the motor from moving in that direction. There's one on the bottom, one on the top. They're actuated by this little device right here, which is nothing more than a guide. When the gate gets low, it's that stops it. When it gets high, it's the upper one, stops it. It also shows up on the screen, so you know you've hit your hard limit. Now, the difference between a hard limit and a soft limit is the soft limit is set in software. The hard limit is set in hardware, so that if for any reason the software fails, you have a hardware backup. We at Watch Technologies always want to make sure that something's going to work. Here's your antenna. The gate is our standard. This is a typical mild steel gate that's powder coated. UHMW guides here. Neoprene seals on the bottom. In this case, the blade is made of aluminum for lightweight, and stainless steel bolts. Of course, it has a frame to hold it up, but in the real world, it would either slide into some slots that were in the concrete civil works, or it would have a flange coming out that you would bolt it to a flat surface of any kind. So, this is the system. This can be deployed, and once again, I'm going to show you how it can go a long ways. We'll get it way out of distance. Oh, now the gate position sensor right here, this is the gate position sensor. Very, very accurate device. And it's embedded in the actuator so it can't be fouled by any debris. Okay, so we'll put it in the auto mode. Right now we're reading 0.88. Our target is 0.8. So it's not far enough out to do the whole 5-second pulse, but it's going to do its job. Get there and stop. My goodness. Went past a little bit. But 1/100th is of a foot is within the deadband, so it stopped. These antennas, the radios that are deployed in this particular unit are 900 megahertz radios, 0.25 milliwatts, excuse me, 0.25 watts or 250 milliwatts. And that's with no gain antennas. These are virtually no gain antennas. I think they're about 2 or 3 dB gain. Of course, for any real system in the we would put out in the world, we probably would use a much higher gain antenna, which gives you a lot more distance and a lot better signal that you can read. I think that's about it. That's our system, and hope you like it.
The depth thing, you didn't say anything about that.
Oh. Actually, we should demonstrate the any sensor attached to this system, and these particular RTUs can handle up to 6 analog and 8 digital inputs. But this particular device is a depth transducer designed to measure pressure head, and it's very accurate. And you can see now that I'm raising it, and it's lowering the level of water that it's reading over its surface. So we're down, it's probably going to get down to a pretty low number. And that number, when this one sees change in the remote RTUs, it broadcasts that change to the master RTU, which we'll look at in a moment. But this is settling in at about 0.62. And what we can do is take a look over here, and there it is. It's reflecting over here, 0.62 now. Although this is a little lags behind, a few seconds behind, because it doesn't have continuous reading. It's meant to change on this. It's broadcast on change. So you're going to see a little bit of lag time there. Down to 56 now, 55. They're both pretty much in compliance with each other. All right, put this back down. See how long it takes to catch up. Well, it's doing it pretty quick. .47, 1.50. So there's about a 5 or 10 second lapse between them. Now these sensors can be used to measure upstream level, downstream level, flow anywhere in the system. You could have a weather station on board, any kind of sensor that's either analog or digital. These guys can read, and you'll have that data to use in your calculations for how the actuator is supposed to work, either monitoring equipment or operating equipment or operating the actuator itself. Now these actuators can be programmed to work in almost any configuration you could imagine. In fact, we haven't found one that we can't make work depending on any client's requirements. So that's how these level sensors plug in. And that's all we have for today.